the peripheral nervous system. The peripheral nervous system is made up of all nerve tissue that is found outside the central nervous system. Remember I told you the central nervous system, you can think of it as a lollipop, because in that lollipop we will be seeing the brain and the spinal cord. So that's how our central nervous system would look like. When we say peripheral, peripheral comes from the word periphery. Periphery is more related to the outside part or surface, exterior. So it means all nervous tissue found outside the central nervous system, because we divided the nervous system into two. Anything that is central is connected to brain and spinal cord, and anything else outside the brain and spinal cord will then be peripheral. As such, we have nerves that leave the brain or the head. We have 12 of such nerves. We call them 12 cranial nerves. And remember, we then also have 31 pairs. Again, 31 pairs. We have 12 cranial pairs. We also have 31 spinal pairs of nerves that leave and enter the spinal cord. I'm sure by now you should realize we have two major regions here. We have a region that is more or less central, and we have a region that is more or less outside, that is peripheral. You see these nerves here on the outside. We have another region that is on the outside. So the outside ones are the peripheral ones. And here we have the central one, the brain and the spinal cord. So there are in total 43 pairs of peripheral nerves, which are divided into 12 pairs of cranial nerves coming from the head and 31 pairs of spinal nerves. 12 plus 31 should give you 43 pairs of peripheral nerves. And remember, the peripheral nervous system is divided into two. We have the somatic nervous system, which controls all voluntary actions. And we have the autonomic nervous system, which controls all involuntary actions. And the autonomic nervous system is divided into two. We have the sympathetic branch and we have the parasympathetic branch. I'm sure we remember this. The sympathetic branch, from the word sympathy, comes in when you are in trouble because it's active under stressful or emergency situations. And the parasympathetic branch will then be active when you are at rest under normal resting or restful conditions. Every organ then of the body receives nerves from the parasympathetic branch of the autonomic nervous system, and as well a nerve from the sympathetic branch of the autonomic nervous system. It therefore means, for example, the heart would receive a nerve from the sympathetic branch as well as a nerve from the parasympathetic branch, each one of them touching it. And I would like us then to realize that the heart is touched here twice. Okay, since it's touched twice by two nerves, we refer to it as double innervation. Such that this is so because the two branches function in opposition to one another. The effect of one is the total opposite of the other. So that when the sympathetic branch, through its nerve, which is touching an organ, becomes active, it will set that organ into activity according to how it's supposed to act when it's the sympathetic branch, and vice versa, the same for the parasympathetic branch, will cause an organ to act in a specific way because it is also sending its own nerve to that organ. So then, the sympathetic and parasympathetic branch will then function as we are seeing in this diagram here. For example, if the sympathetic branch, if the parasympathetic branch, for example, if the parasympathetic branch is active because it's touching the pupils of the eye, it will cause the pupils to constrict, become a bit narrower. While when you are under stress, you are afraid, because your sympathetic branch is touching the pupils, it will cause the pupils at this point to dilate. When you are at rest, no stress, if the sympathetic branch is touching your salivary glands, it will cause an increase in the secretion of saliva. Meanwhile, when you are stressed, if you care, you can you can test it for yourself, sorry. If you want, you can test it for yourself. When you are stressed, when you are in fear, you will realize that you have little saliva left in your mouth. Your mouth is basically dry because the sympathetic branch causes decreased secretion of saliva. We can then look at the rest step by step. The parasympathetic branch will slow down the heart rate. When you're at rest, you are not worried. But when you are worried, you are afraid, your heart rate increases and your heart starts beating fast. Okay. And the sympathetic branch will also inhibit peristalsis and secretion that occurs within the alimentary canal. For example, the muscles of the alimentary canal, they are always, if they are involved in digestion, then they should be contracting and relaxing rhythmically, such that it causes what we call peristalsis, or peristaltic movement of this alimentary tract. So when you are in times of fear or danger, since muscle contraction and relaxation expend energy because it uses energy, the energy that's supposed to be used for the peristaltic action of the walls of the alimentary tract, that energy is not necessary to be used when you are maybe either fighting or running away or fleeing. That energy is wasted if it's used for digestion, because digestion cannot help you in any way to overcome stress. So the energy is saved and sent to the muscles, which will rather be active, to the muscle, the brain, and the heart, which have to be very active for your survival. So in times of fear, that is why the sympathetic branch will prevent contraction or peristalsis of the alimentary canal or secretion. Meanwhile, when you are now fine, there's no pressure, there's no stress, the parasympathetic branch will stimulate peristalsis and secretion so that digestion can go on properly. And in the same way, it will stimulate bile to assist in digestion. Meanwhile, the parasympathetic branch will inhibit bile's production or release. The sympathetic branch, again, under times of fear, will stimulate increased glucose production or stimulate the conversion of glycogen to glucose to release more energy. And again, it will stimulate the secretion of the hormone adrenaline, which is the fight or flight hormone, which will also come and have more or less the same effect as the sympathetic branch. In a nutshell, I'm in this case here trying to say that adrenaline will do more or less everything that the sympathetic branch is doing. The moment it is released, it will take up all these same functions. It means adrenaline and the sympathetic branch of the nervous system have more or less the same effect on the body. Okay, we'll see that. Thyroxine as well. Again, the sympathetic branch will inhibit bladder contraction, so that when you're in times of fear, when you're fighting, you should not be peeing and fighting at the same time. Meanwhile, this one here will stimulate bladder contraction so that you can pee, put yourself at ease when you have no stress. Thank you for attending. Enjoy your day.